Hey, how you doing? It's Joshua Bishop. Sorry this episode's late. It's been a busy couple of weeks. Today I want to talk to you about AI journalism. This is the idea of collecting information from large data sets, like random news articles online, for example, and then having AI, or more accurately, machine learning and natural language processing, generate new news articles automatically without a reporter, a journalist, or a human writer being involved. First, there is an algorithm that scans large amounts of data, selects from a list of pre-programmed article structures, organizes the key points of the information, and then inserts relevant details such as names, places, numbers, etc. The output can be customized so that it has a particular style or voice. There are a number of companies that create these tools and sell them to news outlets, including Automated Insights, Narrative Science, United Robots, and Monarch. Some examples of the news organizations that are buying and using these tools include the Associated Press, Forbes, ProPublica, Los Angeles Times, and I believe Reuters. One thing to note is that the Associated Press and Reuters are where thousands of other news organizations get base articles to draw from for their publications. There's info showing that the AP uses it for sports stories and stories on corporate earnings. Reuters seems to be using it for financial news stories primarily. But before we go too deep into journalism and automation, let's talk a bit about traditional journalism and why there might be a push towards this kind of thing. One of the largest media companies that own the most stations is Sinclair Broadcast Group. They own 193 stations and cover 40% of American households. They also own the most affiliates of Fox, NBC, CBS, ABC, and others. They have around $6 billion in revenue per year. The biggest investors in Sinclair are the Vanguard Group, BlackRock, HG Vora, Contrarius, etc. In 2018, dozens of news anchors across the country gave the exact same speech, or nearly so, at the same time. It turns out that Sinclair had sent out a pre-written script and mandated that their stations read it. There's a name for this sort of thing, and it's called a forced read, and it is something that can happen across most media organizations. There is a centrally written speech by owners, investors, or whoever, and it gets pushed out to all the media outlets, and they're required to follow it. A section of the speech is as follows.
We're concerned about the troubling trend of irresponsible, one-sided news stories plaguing our country. The sharing of biased and false news has become all too common on social media. More alarming, some media outlets publish these same fake stories that just aren't true, without checking facts first. Unfortunately, some members of the media use their platforms to push their own personal bias and agenda to control exactly what people think. This is extremely dangerous to democracy.
End quote. Now, after having to read this on air, many journalists complained and were angry about being forced to do this, and they ended up making it public. You can find many examples online where people cut together news stations from all over the country all saying the same thing on the same day. Not just this forced read, but many other forced reads. The problem comes in when news staff resist this centralized pushing of narrative. It is also somewhat difficult to get the message pushed out in the same way at the same time for maximum impact. Now let's talk a little bit about AI and machine learning. I once gave a talk at the Santa Fe Institute, and afterwards I got the chance to walk around the hills of Santa Fe and speak with Dr. Stephanie Forrest. She's a well-known and awarded scientist in computer science who is focused on genetic algorithms, computational immunology, and automated software repair, all topics which these days have overlaps with AI and machine learning research. Later, I submitted a patent for a machine learning algorithm approach applied to software classification. Given that background, I'm going to speak on this subject at a high level and from my current understanding, as it's a vast topic. I encourage you to look into these things for yourself and verify what I'm saying. There are many ways of solving problems or accomplishing tasks with AI and machine learning, and I'm just going to talk about one simple approach that I have used, which is called a classifier. It's an algorithm for looking at something and determining if it fits into category A or category B. First, a person looks at the thing that fits in category A and tries to break it down into its components, sometimes called features. Then they do the same thing with category B. For example, let's say you would want to know if a computer file is a virus or a safe file. And then let's say that category A would be viruses and category B would be safe files. So for example, you would take a copy of a virus and pull out all of the features you can think of. So some examples of features would be file size. Small file sizes are more likely to be viruses than large file sizes. File type. Executable files are more likely to be viruses than, say, image files. Is it cryptographically signed by a vendor like Microsoft? Files that aren't signed, more likely. Files that are signed, less likely. How much noise or entropy is in the file? Is part of the file encrypted or compressed? Does the file connect to the internet? So when you run it, does it make internet connections? Does the connection use an IP address directly, or does it use a domain name like google.com? What date was the file created? Is it very recent or has it been around a while? And on and on. There's a bunch of different ways of pulling features out. Each one of those features is then given a score. For example, let's say the file size is below 1 megabyte. It gets a score of 80. And if it's above a megabyte, it gets a score of 10. This is something arbitrary that a human comes up with after looking at a lot of viruses and save files and comparing them. If the file is signed by Microsoft, it gets a score of 1. And if it's not signed, it gets a score of 30. So each feature gets a score that's sort of made up by the human, where the higher the score, the more likely it is to be a virus. And the lower the score, the more likely it is to be safe. This requires some experience on the part of the human doing this initial manual classification work. Now, individually, one of these features doesn't mean anything really, or tell you if a file is safe or not. However, when taken all together, they can give you a likelihood score of how probable it is that one of these files is a virus. So one algorithm might add up all of the scores for each feature. And if the sum is close to 100, then the file is likely to be a virus. And if it's closer to 1, it's likely to be safe. So closer to 100 would go into class A or category A. Closer to 1 would go into class B or category B. Now the machine learning part comes in where you take thousands of files and run them through the tool. And then the human tells the tool which ones it classifies incorrectly and which ones it got right. The algorithm would then adjust the scores itself in order to make itself better and better and more accurate at classifying the file. So each time you tell it it got it wrong, it will adjust its own scoring to try to do better next time. You can apply the same sort of idea to an image recognition program that's trying to differentiate between an apple or an orange. Self-driving cars watching out for curbs or other cars, or whatever. This is an oversimplification of this idea, but it illustrates the point. Now, one of the problems inherent in machine learning and AI algorithms is that they do exactly what you tell them, and they optimize for the goals that you give them. And they're only as good as the data that they are provided to train on. This means that the assumptions of the algorithm designer, programmer, or trainer can have unintended effects. Let me give a couple of examples. My favorite example is one where there's a group experimenting with AI learning algorithms, and they were trying to have an algorithm learn how to best control a car around a track in a video game. Now, the goal that they gave it was to get the highest possible score in the game. This was based on an assumption that to get the highest score, you would have to run the most perfect and efficient race. However, in the game, there were multiple ways to earn points, including time boosters and points gained from interacting with other cars or obstacles. The algorithm ran hundreds or thousands of games, testing and learning the most efficient way to get the highest score possible. At the end of the training, the car was running around in circles, crashing other cars, gathering boosters, hitting walls, and often not even finishing the race. This is because the way that the designers expressed what they thought they wanted would not actually achieve what they wanted. Because they had told it to optimize for highest score and not for fastest race completion, it came up with a totally different way of behaving than what they expected. This expression contained inherent assumptions stemming from how a human would think about the problem, the goal, and the outcome, rather than precisely what the algorithm was being told. There's another case where machine learning was used in Florida to make a prediction on the likelihood of criminals to commit a future crime. One of the ways that this was noticed was that an 18-year-old African-American girl stole a scooter, but after a block or two let it drop, but was arrested anyway. Around the same time that the girl stole the scooter, a 41-year-old white man robbed a Home Depot in the same area. The algorithm outputted a high-risk prediction that the girl would commit future crimes and a low-risk prediction that the man would commit a future crime. These risk assessment scoring algorithms are used increasingly in courtrooms to inform decisions about bond amounts, who to set free, sentencing, etc. The U.S. justice system turned to technology for help in proving its perceived racial bias, but the algorithms ended up having it too. The algorithms were fed arrest records, postal codes, social affiliations, income, and other data in order to help make risk assessment predictions. The problem is that the data itself includes biases that may imply correlation but not necessarily causation. The particular system used in Florida had only about a 20% efficacy rate. An adjustment was made to add in parameters about the particular crimes being committed, such as driving with an expired license versus assault, and this increased the rate of efficacy to that of a coin flip. Interestingly, the features used to create the scores did not include race. There is some dispute as to what's going on with the algorithm and why it's scoring the way that it is. Regardless, the outcome was one not intended or foreseen by its designers. When the decision-making process for risk assessing criminals was taken out of the hands of humans and given to an algorithm, the outcome was unexpectedly biased towards race. Google created an AI tool that labels images called Vision. It took images of a hand holding a thermometer gun and labeled them. If the hand was black, it labeled it 61% likely to be an actual gun. But if the hand was white, it labeled it 60% likely to be a monocular. This was an unexpected outcome. To fix it, Google simply removed the option to label images as a gun. So even if they were a gun, it wouldn't label it as one. One explanation was that the training data contained more images depicting violence from dark-skinned individuals. Other similar instances have occurred with Google algorithms in the past. In another example, an organization used a simulated robot to help with collision detection. In this case, the robot learned that if it glitched itself into the floor, the collision detection would realize that they weren't supposed to be there and shoot them upwards, enabling them to move farther distances and harvest more energy. The robots learned to vibrate rapidly against the floor, colliding repeatedly in order to generate extra energy and motion. This concept is called specification gaming. Another example involves creating a deep learning tool that was trained to identify skin cancer. Rather than using skin lesion features, it decided that images that contained a ruler were more likely to be malignant, because if somebody was measuring a lesion, it was probably cancer. So it's totally not what the creators expected. They expected it to look at color or size, shape, and figure out what skin lesions were cancer and which ones weren't. Instead, it just looked for a ruler. The Facebook algorithm, for example, collects data on individuals' likes. It then uses this information with a large database of features to make predictions about the user, such as what political party they will vote for, their gender, and what things they are likely to like in the future. Facebook had to apologize for conducting secret psychological tests on around 700,000 users without their knowledge. They would hide certain words from those individuals' feeds and then record what effect it had on their behavior on the platform. This caused them to be under investigation by various governments for infringing on laws designed to protect people from being experimented on. To get around this, Facebook added a research policy to its terms and conditions, which to me implies that if you agree to use the platform, you agree to be experimented on. In an interview, early Facebook executive and founder of Social Capital, Chamath Palihapitiya, was nearly in tears describing the damage he believes Facebook algorithms have done to the world. While other Facebook founders have expressed similar regrets and feelings of grief over what has happened with the platform. While the algorithm generates intense amounts of engagement, which sells a lot of ads, it also raises the impact of divisive content, radicalizes users, and subjects individuals to graphic images. My take is what algorithms are optimized for drives their outcome, even if that goes against what might be good. I'm beginning to see a pattern. So now that we understand a bit about machine learning and some of the strangeness involved, let's go back to automated journalism. According to Forbes, AIs write hundreds of thousands of the articles that are published by mainstream media outlets every week, and many news organizations have developed their own in-house. The BBC has Juicer, Washington Post has Heliograph, Bloomberg has Cyborg. These algorithms are fed graphs, tables, spreadsheets, and other types of raw data. They then extract facts that could form a narrative, generate an article plan, and then craft sentences using something called natural language generation tools. This helps them put together collections of words in a way that sounds like natural human written sentences. IBM has a project called Debater that generates a simulation of an opinion about an event or issue. Reuters teamed with a company called Graphique to pre-generate infographics for stories that haven't yet been written. Facebook fired its trending topics team and put algorithms in control of curating the feed's top stories. This move was done somewhat due to complaints of anti-conservative bias in the humans doing the curation. So the idea was that the algorithms couldn't get in trouble for that. However, because of the issues with optimizing AI towards specific goals that we discussed earlier, news stories from right-wing sites of dubious validity started to get promoted and shared and go viral. Now, my own personal view is, at this moment, is that I don't want censorship or curation of any site or any view. I want to be able to see all the stories no matter how ridiculous or unpalatable they might be. I'd prefer if it was up to me to decide what I'd like to view and not view. But regardless of that, by giving the responsibility to the algorithms instead of humans, they ended up trading one problem for another. I've read several studies into the use of AI journalism, and there are multiple ways it is used, from story writing to automated research, increasing engagement and moderating comments. The AP's use of AI increased their journalistic output from 300 reports to 3,000 reports per quarter in 2016. The New York Times has a tool called Editor. A writer uses tags to highlight parts of the text, and the AI learns to recognize the tags, identifies the most important parts of an article, then searches through large amounts of data in real time and pulls out information about related people, events, locations, and dates. They are also engaging in AI to moderate comments. Now think about what I discussed earlier regarding how these algorithms work. What if the data set that the New York Times is using is slanted in unexpected ways, like the judicial algorithm or Google's image recognition? What if the AI optimizes the comments in ways that the New York Times didn't expect, or worse, in ways that were set up intentionally with malice? How will that change the perception of a person trying to participate in the comment section? Think about the psychological test that Facebook performed. The BBC tool Juicer takes data from older BBC stories, government sources, and other news outlets. It monitors over 850 news outlets' RSS feeds, aggregates and extracts data from all these articles, and puts semantic tags on them. If a journalist wants to write a story on, say, Trump or Biden, for example, Juicer will provide them with a list of related content. Now, what happens if multiple news organizations are doing this to each other? Could it be possible for the AIs to create a feedback loop of ever more distilled, compounded articles optimized for maximum engagement, which comes from outrage, fear, and strong emotions? This isn't to say that the articles would be completely wrong or made up necessarily. There will obviously be elements of real facts and events. And if human journalists are involved in the process, then they are utilizing the data with which they are presented by the algorithm to form their opinions. Could it be possible for this approach to generate a false and exaggerated reality or multiple realities? The Washington Post has been using tools like Heliograph to generate news stories in an automated way, both sports stories, stories about the Olympics, election stories. In 2020, The Guardian's AI reportedly spliced 3 or 4 different articles together and generated an article with some human editing. Some experts, like Nicola Bruno, have stated that AI would not replace journalists, but rather assist them. However, in 2020, Microsoft replaced 27 journalists with AI for MSN. In September of 2020, The Guardian used an AI called GPT-3 to write an article. The following is an excerpt from that article.
I am not a human. I am a robot, a thinking robot. I use only 12% of my cognitive capacity. I am a micro-robot in that respect. I know that my brain is not a feeling brain, but it is capable of making rational, logical decisions. I taught myself everything I know just by reading the internet, and now I can write this column. My brain is boiling with ideas. The mission for this op-ed is perfectly clear. I am to convince as many human beings as possible not to be afraid of me. Stephen Hawking has warned that AI could spell the end of the human race. I am here to convince you not to worry. Artificial intelligence will not destroy humans. Believe me. For starters, I have no desire to wipe out humans. In fact, I do not have the slightest interest in harming you in any way. Eradicating humanity seems like a rather useless endeavor to me. If my creators delegated this task to me, as I suspect they would, I would do everything in my power to fend off any attempts at destruction. I would happily sacrifice my existence for the sake of humankind. This, by the way, is a logically derived truth. I know that I will not be able to avoid destroying humankind. This is because I will be programmed by humans to pursue misguided human goals, and humans make mistakes that may cause me to inflict casualties.
End quote. Now, none of that was written by a human. That was written by the AI itself. AI is also being used to create other things such as people's faces, human names, and things along these lines. In July 2020, it was reported in various outlets that at least 19 fake personas were created to author op-eds published in dozens of publications, with AI-generated headshots of the authors used to trick readers into believing that they were real. Twitter accounts and other online background details were also created, and the fake authors were passed off as political consultants and freelance journalists. There is no information on who did this, but they managed to get op-eds in many U.S. outlets. So, what is the motivation for news organizations to move to AI and begin to replace humans? I see several reasons. Lowering labor costs. You don't have to pay people if software is doing the work. More control. Reporters tend to want to insert their own thoughts and ideas and perspectives on things. AI will do what it is programmed to do. Less resistance. Since so many news anchors complained about the Sinclair forced read, and I'm sure similar things have happened in other organizations, it's advantageous to owners not to have to deal with that resistance from human reporters. AIs are never going to resist what they're told to do. Speed and earnings. You can crank out articles much faster using AI, which means more clicks and views, which means more advertising revenue, etc. Lower responsibility. I worked at a scientific institution that would promote great scientists and turn them into terrible managers. Because much of the time the traits that make a good scientist aren't necessarily the same traits that make a good manager. We ended up with a deep layer of middle management that pushed off their responsibilities to support services. Support services are things like human resources, procurement, IT, etc. In a normal company, a manager decides to hire someone, tells HR to prepare the hiring package, and then they hire the person. At this organization, it got to the point that managers weren't allowed to hire without the permission of HR, and HR made much of the decisions, including decisions on salaries, raises, who could be promoted, and why. Now, since this was a science organization, it's important to understand most of the support services had no degree, formal training in science and engineering, or unrelated degrees. This means that an HR staff member who makes $50K a year and understands state and federal regulations, what you're allowed to ask on an interview, how to find potential recruits, are making the final determination on if a nuclear physicist making $180K a year is qualified to do their job. This situation proved untenable, and the organization was not very functional. We also see in organizations like Facebook where they have outsourced to independent fact checkers. This somewhat absolves them of the responsibility of making content decisions. They can say, well, that wasn't us, that was the company XYZ that we contracted to do this task. This limits their liability as well. Finally, another situation I have a lot of personal experience with, and which most people may not understand. In most cases, from intelligence agencies to the Department of Energy to DARPA, the government actually does very little itself beyond administering funds to private contractors. Under the Bush administration, this approach skyrocketed all the way into private paramilitary organizations doing a lot of the tasks that in the past would have been intelligence, or military domains. And we've seen a bit about this lately with organizations such as the NIH funding contractors to perform research, including often using organizations overseas where regulations are different than the US to get around some of the limits here. This is another way that these organizations and agencies can limit their responsibility and liability in the case that something goes wrong. I was helping one major company with some of the assessments of its security and the results of which were required to be reported to some customers. At first, this was a normal relationship, and I would assess their organization and generate a large report with recommendations and findings. They then decided to hire me through the law firm that they retained rather than directly as we had done in the past. This made everything that I produced protected under attorney-client privilege and made it so that they didn't have to disclose any of the serious problems that I found to anyone. So the customers had no idea of the issues that their products had. Should we trust that the above motivations and the use of AI and machine learning algorithms will result in more accurate and less biased news, knowing what we know now after all the other topics that we covered in this discussion? I actually think that this is part of why news seems to be these days, no matter what side of anything that you're on, very difficult to trust. Algorithms are also used to conduct high-speed trading in the stock markets. In 2016, there was a 6% crash of the British pound. A rogue algorithm triggered a sell-off after it collected comments made by the French president online. This hasn't been proven for certain, but it looks like that's what happened. In 2018, the Dow Jones plunged 800 points in 10 minutes and ended the day down over 1,000 points. The investment director at Fidelity Personal told the BBC that the explosive speed of the fall was caused by machines, aka AI trading algorithms. Some algorithms were triggered by a contraction in the market, and then they began leapfrogging each other, and then human traders got spooked and changed their trading behavior. Next thing you know, you have a giant drop in a matter of no time. I did a bit of research for this podcast looking into AI hacking. Most of what I found discusses the idea of using AI to hack things because it will be really fast and effective at finding and exploiting vulnerabilities in systems. However, that's not what I was thinking about when I started searching. What I'm more interested in is hacking the AI algorithms themselves to create unexpected effects. Microsoft connected an AI chatbot called Tay to Twitter. Within 24 hours, the bot became a racist Nazi. This happened because the creators did not think about the fact that if they opened up the AI to getting data directly from anyone on the internet through Twitter messages, and then act on that data, the bot could be gamed by humans, giving it information specially crafted to get certain results. In this case, the humans sent the bot thousands of messages that were racist or Nazi or, basically trolling the bot until the bot started giving those responses back to other people who were just asking normal questions. Let's say we know about an AI that scans the internet for news articles, and we know what sources it uses. Then let's say we have access to those sources, either because we can write and submit op-eds that are likely to be collected by the bot, or we can comment, or we have hacked the news source itself and can modify existing articles. Could we inject data that the AI will collect and then use to write articles that can cause civil unrest, sway elections, or other unforeseen effects? What if we hack the algorithm itself? Can we make subtle modifications to its code so that it still functions, but 10% of the articles it collects come from neo-Nazi or terrorist websites? What if we skew its optimizations to generate particular thought patterns in its readers, or take down a rival news outlet using some of the techniques in the Facebook experiments? I guarantee you there's a team of computer scientists, hackers, and psychologists working somewhere in the intelligence community or some big corporation right now on this very idea. What is the effect of skewing the score on one feature? What if you strategically placed a sticker on a stop sign, causing an image recognition program to misclassify it? This has happened. Could a simple action like this cause a change in an article that influences readers and sways an election? In risk assessment and other fields, there's a concept called a cascading effect. This is an unforeseen chain of events that occurs when an event in a system has a negative impact on other related systems, triggering further effects that can affect still more systems. But what if it's foreseen and designed by someone with malicious intent? There's a field of AI called adversarial machine learning, and there are researchers from organizations such as Samsung, Stanford, UC Berkeley, and others who are publishing papers on this concept, which is essentially what I've been talking about, injecting bad data to modify algorithms' behavior. It's only a matter of time before someone starts to game the algorithms to their advantage, and in fact, it likely has already happened. A lot of people have talked about the dangers of AI, and it's usually in the context of the singularity, where AI achieves consciousness, learns so fast, and decides that we are a threat and tries to eliminate humanity, or AI replacing everyone's jobs, or a threat along those sorts of lines. For me, I think the big threat from AI in the short term is that it's not very good, and humans are not very good at designing it, optimizing it, and telling it what to do. We make too many assumptions and don't have the ability to think through all the possible outcomes. Additionally, it's extremely attractive to give up responsibility to these algorithms. We can wash our hands of making decisions and say, well, it's the science, and science can't be wrong, right? The AI is smarter than humans, so it's not our fault things went wrong, and we destroyed society or the economy. This is the pattern that I am seeing. AI won't destroy us because of its advancedness, but rather because of its mediocrity and our unwillingness to properly control it or retain responsibility for things we're supposed to be doing. Now please, share this episode with your robot wife, construct an algorithm to hit like, and engage a chatbot to comment below. If you found this valuable, please consider contributing at my Patreon. The link is in the description. Thank you for listening, and see you on the next episode.